will be hearing from our second keynote presentation. We eagerly anticipate hearing from Dr. Kishore Balasubramanian from the Mahalingam College of Engineering and Technology in India. So I cordially invite our second keynote speaker to deliver his insightful talk on transforming ophthalmology and the impact of artificial intelligence and machine learning. While Dr. Kishore gets everything ready, I would like to introduce them as well. Dr. Kishore has over 20 years of imparting engineering education. He achieved his master's degree and PhD from Anna University in India, and his research interests include medical image processing and soft computing techniques. He has authored various book chapters and books regarding analog electronics for AI for medical diagnosis, and several publications in international and national journals. He's been granted over 6 patents in India and published on 3. He's an active reviewer in many index journals and has been nominated as the Bentham Ambassador for the Bentham Science publications for the years of 23 and 24. As an active reviewer, he's also currently working as an associate professor in the Department of Electrical and Electronics Engineering and heads the career planning and guidance at Dr. Mahalingam College of Engineering Technology in India. So, we await your presentation. Take it away, sir.
Thank you. Hope am I audible?
Yes, sir.
Okay, thanks, David, for the wonderful introduction. And myself, Dr. Kishore Balasubramanian, Associate Professor from Dr. Mahalingam College of Engineering and Technology, India. So let me thank the organizers of this conference, the International Conference on Ophthalmology and Vision Science, for having given me a chance to present a keynote address on how artificial intelligence plays a predominant role in disease diagnosis, especially in ophthalmology. So my area of research mainly focuses on how this artificial intelligence can be integrated with ophthalmology in disease diagnosis. My area of research mainly focused on glaucoma detection using artificial intelligence, image processing, machine learning, and deep learning techniques. So let me have a brief outlook on how the presentation of myself would be. Hope my slide is visible.
Yes.
Yeah. So transforming ophthalmology, the impact of artificial intelligence and machine learning is my topic for the keynote. So my presentation will cover the following aspects: a brief introduction to artificial intelligence, an overview of ophthalmology. So I need not brief into the second part. I did not go detail into the second part. And the third part is the integration of artificial intelligence and ophthalmology, and how this artificial intelligence plays a critical role in clinical decision making and how it aids in diagnostic imaging. And the next one will be the predictive analytics, how the glaucoma or age-related AMD-like diseases can be predicted using the machine learning or deep learning algorithms, and limitations and future aspects for this artificial intelligence in ophthalmologic disease detection, and finally will be by conclusion and future scopes. So let me have a brief outlook on what is artificial intelligence. I'm just giving only a brief overview. I'm not going into any techniques or any of the algorithms being presented now. So artificial intelligence, something has to do with a man-made, so it is not natural. So ability to perceive the information and retain it as a knowledge. So this is just to act and think like a human, but it cannot replace the entire human fraternity. So think and act like a human rationally is just like a machine, how it does. Well, the machine gets trained in certain aspects. So this can be done using any of the simulation techniques, how the human intelligence processes certain informations, like how our brain neurons and other activities processing certain information. So the similar kind of simulation is done by AI, but by using machines, especially the computer systems. But nowadays, due to the advent or the industrial revolution and more technological advancements have taken place, and processing by computer systems itself has become very complex nowadays due to high computational cost and high computational resources, and it may think when the data or the volume of the data becomes huge. So again, here there comes the part as big data analysis, so big data analysis and analytics, data scientist. So all this will come under the last part of my slides. So intelligence, we will be able to know it is something like problem solving or critical reasoning or critical thinking, and about learning by itself. So learning by itself or learning by perception or something it may be, and it may also adopt to certain new situations where the data is very complex, or the image or the signal, whatever you give, it is very complex. Then the simple thing is to define as ability of the machine to make a decision, predict the future, learn and improve on its own. So now artificial intelligence has taken a place in the world. It has been used in all walks of life, starting from medical diagnosis. It can be used in fraud detection. It is used in financial sectors, banking sectors, and whatnot, robotics and other walks of life. So artificial intelligence is being used in all walks of life, wherever we go, starting from wherever we get up early in the morning and we go for the sleep at night. So the simple components of artificial intelligence may include applications where AI is being used, and what are the models that has been used for artificial intelligence, and how it is being implemented, or how AI is being deployed as a model. So for this, we need to go for two important components. One is the software, other one is the hardware. So software or hardware, it requires some training, or it may be running modules where you need to have different workstations for processing the huge amount of information. So like parallel processing tools, graphic processing units, that is GPUs, what we call in technical terms, and the recent advancements, cloud data storage. So it's being offered by Amazon Web Services or Google Web Services, whatever platforms are available, and what we normally term it as computing platforms. So that we call it as Google. So cloud data storage, where you can store a huge amount of data, retrieve it, and process at a later point of time. And how to deploy these models in all these software or hardware modules is the programming language what you build these models upon. So recently used tools may include Python, TensorFlow, Java, and C. You may also use MATLAB, that is mathematical modeling, for creating all these models. But due to the advancement, that is for analyzing a particular, or for creating a particular model, you may have some 50 to 60 lines of coding. But when you use it in Python or the open source softwares available nowadays like TensorFlow, so you may reduce the number of lines of coding. So with that, you'll be able to achieve a better accuracy than you do with other models. So depending upon the complexity of the data, and due to the advent of recent architectures, we'll be able to use different programming languages as well. So nowadays, some programming tools also making use of R language. So that is also nowadays have taken place. Then this is the AI landscape, where the entire concept of artificial intelligence is being given here. So this is just an exhaustive way. Machine learning, deep learning. So in that you have neural networks, how human neurons work like. So this is an artificial neural network. And pattern recognition, which is a very important concept nowadays being used. Natural language processing, you are converting text into images or text into any other languages. And of course, maybe making use of chatbots nowadays. Chat GPTs have also come. And real-time emotion analysis, which is being used for face recognition in psychiatric disorders also. So these are also being used in nowadays. And most recently, we have gone into robotic surgeries, where we make use of autonomous surgical robots for doing robotic surgeries. And the last one, what I want to say in this particular slide is quantum computing, which is taken or which is just gaining importance nowadays. And this neuromorphic engineering is also a niche segment where there are less number of papers under our belt. So what we know from our technical point of view. And this is the simple area where you can have artificial intelligence, machine learning, and deep learning. So these are the three entire areas where all the AI models are being deployed. So deep learning and machine learning are subsets of artificial intelligence, and in that deep learning you have machine learning, you have deep learning as another subset. So machine learning, it just deciphers certain problems which you see using our eyes. That is visual perception, that is video signal analysis, or you may call it as audio signal processing is also possible. That is speech recognition. So based on all these information, your machine will be able to make a decision on its own. But this machines has to be trained on certain data, which is also available as a ground truth value. So deep learning, it is another advanced version where it does everything. So you need not to train the model from the scratch. So it will do it on its own. So it is something like supervised and unsupervised manner. You can just tune the architectures or the neural blocks what you are using, and that also involves certain algorithms which make the architecture very smooth. So in that architecture again, very well algorithms are being used, like bio-inspired algorithms, physical algorithms, so which make use of swarm intelligence. So this mimic all the animals outside or human thinking genetic algorithms. Everything's are now being used in deep learning and machine learning algorithms. So these plays a pivotal role in medical diagnosis and almost in all walks of life. So I'm just skipping these things. So on how to deploy a particular artificial intelligence model, so you require an machine learning framework where it requires a lot of processing power and storage. So some of the examples what I have given here to run an AI model with a few lines of code, it is PyTorch, where you can go for Python language, TensorFlow, which is again an open source CV, and Cafe too. So these are simple processing algorithms, computing platforms available nowadays for artificial intelligence and machine learning pipelines. So you can use any sophisticated infrastructures, but the complexity lies in how deep the network is, how deep the neural concept is, how deep the neural network is. So AI hardware, again, I'm just talking about GPUs. So some of the companies which manufacture those GPUs are given here. So NVIDIA, you might have heard about NVIDIA, Jetson, Intel Corporation, Qualcomm, and Google as well. So all these are all developing some co-processors and AI accelerators which help in reducing the complexity of power processing and storage. So some of the popular artificial intelligence models I have shown here. So these are all started from a decade ago until now, that has been followed in the technical aspects where artificial intelligence and other disease diagnosing process are being involved. So deep neural networks, decision trees, and model 7, that is support vector machine. So these three are very important from AI point of view. So all these are being nowadays used in regular practice. So I'm just coming out to the general aspects here. So the role of artificial intelligence in healthcare. So with the emergence of unmanned planes or autonomous vehicles, face recognition, language processing, etc., so we can see the artificial intelligence has instead revolutionized our lifestyle. So that's what we can say. So recent studies, wherever you go, that is while you scout for any literature surveys, you can see an outstanding performance of artificial intelligence, or its potential to perform in some of the important tasks like image recognition, and while you want to process more amount of data, that is big data analysis, what what we call it as, and in especially as the amount of data in imaging centers of ophthalmology is increasing dramatically. Analyzing and processing of these data is in its urgent need. So you need to process the huge amount of data. For example, for ophthalmologies, for our research purpose, we make use of fundus images, OCT images, etc. So while we process these fundus images, we may get certain amount of features about the eye and how these features contribute to disease diagnosis. So all these are being discussed in detail in the forthcoming slide. So in general, we can say that artificial intelligence that is building the blocks of artificial intelligence and systematically reviewing certain applications would definitely lead to an important diagnostic field in ophthalmologic diseases. So, to be very frank, we would like to say artificial intelligence is a broader umbrella, which may be an interrelated process. So, we make use of artificial intelligence or machine learning algorithms to mimic the human cognition. That is, human cognition for gathering or understanding certain complex medical and health records. You can also say that health records in the sense EHR, electronic healthcare records, or healthcare data, whatever we may call it as. So for all these purpose, AI is using machine learning algorithms, computer vision, natural language processing, robotics, and deep learning. So what these do is they recognize a particular pattern in behavior and then create their own logic to give a well-defined output to the end users. So this is a broader outline of what AI does in healthcare. So the use of artificial intelligence, particularly in the sense machine learning and deep learning, they aid in gaining important insights and prediction. That is, in prediction, using extensive amount of input data. How input data you supply, that kind of output you will be able to produce. So those outputs or the results, whatever that come out of an AI model, they can be used as a second opinion. They can be used as a second opinion to the physicians or doctors or ophthalmologists or whoever it may be, or they may be an second expert, you can also call it as, on how to build companions for expensive medical or clinical preliminary. So no doubt, an artificial intelligence based system cannot replace a physician or a healthcare professional, but it just helps in aiding the patients or helps in quick diagnosis and medical management, or in sense clinical management, wherever you can use it. So artificial intelligence uses a wide variety of technologies or algorithms in healthcare industries. So for example, if you use natural language processing, so natural language processing, it creates or understands and classifies certain clinical documents. So clinical documents, while you set it as and put it as an image, so it will extract the information by creating, understanding, and classifying the documents, and you can also make use of some published researches as well. So it helps in analyzing the unstructured clinical data on patients and preparing the reports. So this is a general thing and natural language processing, which is an advent of artificial intelligence uses. So, and of course, you know about robotics, how robotics plays a very important role in healthcare sector. So surgical robots are being used to provide or are used to help the surgeons in improving their ability to stitch wounds, or something like they are also used in pregnancies as well. So some surgical procedures that use robotic surgery, or that is gynecologic surgery, prostate surgery, neck surgery, or head injuries, head surgeries, etc. Then the other thing, whatever we may use it is radiology. So we can also make use of radiology. So the use of artificial intelligence in radiology is gaining nowadays very important because of the detection of brain tumors, or some kind of tumors which may occur, like breast tumors, ovarian tumors, etc. So for this, imaging plays a very important role. You may have computerized tomography, CT images, magnetic resonance images, PET, positron emission tomographic images. So different kinds of multimodal images are being used nowadays in radiology. So through the algorithms developed through artificial intelligence, we can detect. In recently, we had gone across some COVID times, so that in pneumonias in patients, that can also be detected. So many papers have shown better accuracy in detecting pneumonias from x-rays, chest x-rays, and psychological aspects as well. So they also provide some better results compared to the that is on going on improving from decades to decades. So in all these aspects, we can just say that artificial intelligence is gaining a very important role in screening, how you screen the patients. For example, it is used in dermatology. So dermatologists can detect around 90 to 80% of the skin lesions what they have using thermographic scanners. So for these things, recently developed AI algorithms like Google DeepMind. So this is a very important one being recently developed, which detects the breast cancer at a very early stage. So which will pave way for preventing from reaching to the advanced stages. So, but it is just in second opinion, but we need to answer, or we need to compare the same results with clinical trials as well. So again, they're also used in prostate cancers with better accuracy, and we can go on telling the applications of artificial intelligence in healthcare, like psychiatric diseases. Like recently, more papers have been developed for Alzheimer's disease, Parkinson's disease, and schizophrenia. So psychometric applications are huge. Then again, primary care also, we have support decision mechanisms. Primary health cares also make use of artificial intelligence as well. And for example, we can make use of this disease diagnosis and from electronic health records as well. So electronic health records, where we make use of machine learning classifiers and natural language processing, NLPs, are making use of. Dermatology, of course, skin lesion diagnosis are being used, and carotenoids, I mean skin cancer detection. So for all these things, we can make use of neural network architecture to identify the skin cells from a microscope as well. So all these things are the applications of artificial intelligence and image processing. So how an image or a skin image is being processed and useful for predictive analysis. Again, drug interaction, that is drug delivery systems. So drug delivery systems also, we can make use of machine learning algorithms, and how to manufacture these drugs. They also, that is using artificial intelligence, it is becoming easier and less time consuming as well. So for example, with the help of artificial intelligence, molecule drug for OCD, that is obsessive compulsive disorders. So this treatment becomes very simple, easier for the clinicians as well. So, and again, we can make use of all these things, that is applications that is going on. It's a very huge process. So I'll just skip all from now on. And exponential increase for artificial intelligence in healthcare. Simple applications where you can make use of artificial intelligence is improving the medical diagnosis and speeding up the drug discovery, and transforming the patient experience, and the management of healthcare data. So management of healthcare data, again, I have to put into the term here, tele-ophthalmology or telemedicine or biometrics. So I mean, all these things will come under this managing healthcare data, and performing robotic surgery, which is a very recently thing going nowadays. Then some of the companies which make use of artificial intelligence in healthcare, that is, they develop their own artificial intelligence models and healthcare diagnosis models. So Else AI, Evidation, Takeda, CloudMex. So I have just given only a few who make use of artificial intelligence and then use it in decision making. But there are other companies also which make use of AI to help in healthcare. So this is a general block diagram of a typical machine learning based computer aided diagnosis system. This is an exhaustive one. So the first block is the signal transformation. So the signal can be either an image or it can be a analog signal, whatever it may be. So the input has to be given, and this signal, the input can be anything. It may be a raw EEG signal, a raw EOG signal, or a raw image. It can be, that is fundus image or OCT image, anything it can be. So the raw signals, we cannot use it for a general purpose, but this has to be transformed into the machine acceptable model. So that we call it as a signal transformation or image transformation. So normally what the fundus images, what we get from the data is, it is an RGB model. So red, green and blue model. So this has to be converted into a grayscale image generally for processing into any system, but we can also use each and every signals, I mean channels as well, three different channels also we can use, but normal transformation is just converting into a grayscale image where we can reduce much amount of noise available in the segment in the input image, because the input image or the input signal may be acquired from any point of time. It may be under a blur illumination, so poor illumination or very bright illumination, whatever it may be. So the image or the signal may be affected with artifacts or noise which has to be removed. So that is what we give the term here as signal transformation. So from the signal transformation, we go for certain feature extraction. So feature extraction is, the features means they are the visible marks from the signal or from the image. So that will pave way for classification of that particular input. So for example, we take certain features like texture features, we have certain power features, fractal features. So all these can be extracted from that particular image. So from this, for example, from the fundus image, we'll be able to extract all those features, and all these features will be or will not be useful for decision making. So there may be some redundant features, there will be some irrelevant features. So all these will not contribute to disease diagnosis. So from there, we need to go for dimensionality reduction, that is reducing the complexity of data. So the dimensionality reduction here, I'm just talking about lossless reduction. That is, if any information is lost, then you will not be able to get better accuracy or better classification result. So dimensionality reduction, that plays a very important role. So there also we have different algorithms which make use of certain techniques to extract only the relevant features. So some 100 or 250 features are being extracted from an image, for example, we take. And optimal feature selection or ranking. So I cannot use all the 100 features for classification. So you may that may lead into an unwanted error, or that may lead into a much more time complexity. So for that, I need to select only the important features which will contribute for disease diagnosis. So I will start ranking those features. For example, energy feature, entropy feature. So all some different features are there from the images. So for example, fundus image we'll be able to go for energy, entropy, and some other features as well. So I need to rank them based on certain criteria. So I'll just skip, or I'll just have a thresholding level. I'll just fix it to 10. So what are the features which has come below this 10, or I'll take it for my classification. So then all these ranked features will be given for an AI model. So that is coming under the classification. So this AI model will be trained on these features. So now this artificial intelligence model will be pre-trained using certain images. That is, they will be pre-deployed as well. So you may have certain offline images as well. So for example, glaucoma images or diabetic retinopathy images, they are available in plenty in offline mode. So there is a website, we call it as Kaggle. So where we get much amount of data for diabetic retinopathy or AMD or glaucoma detection. So there are huge number of fundus images available there. So they are ranked or they are classified in that feature itself. So for example, when you take glaucoma, So the stages of glaucoma, they are segregating. So this is a healthy image. So this is a mild glaucoma, that is starting stage of glaucoma. Then it is an average, that is moderate glaucoma, then severe glaucoma. So we may be classifying it under some 3 or 4 different headings. So your AI model will be pre-trained on those already available database. Now you get an input, raw input from a particular segment, and then you process all these information and again you give to the AI model. So those two things will be compared. So based on the comparison between the already trained model and this model, that we call it as training set, and this we call it as a testing set. So when this training set and testing set are given to the artificial intelligence model, so depending upon the trained, how this artificial intelligence is being trained, the diagnosis result is being produced. That is, this particular image is diseased, this particular image is a healthy image. So how many images you train, so depending upon that, your accuracy or your precision of this precision of your model can be calculated. So the CAD systems using artificial intelligence and advanced signal processing techniques, they can aid the clinicians in analyzing and interpreting psychological signals and images as well, with better effectivity, and it may be used in early diagnosis as well. So this is a simple architecture, what I have used here in the classification model. So this is a convolutional architecture for the neural network. So this consists of different layers. So all these layers are just, I have given it as for an example purpose. So we can modify these layers, we can add layers, we can delete layers, whatever we can do, and all these things. However, how many layers you create, that how many deep is your neural network. So deep neural networks, they depend upon how many layers you give, and more the deeper, more the accuracy will be, but it will take computational time will be larger. So these are some of the CNN algorithms being used nowadays for artificial intelligence diagnosis. So our models that has been given here: AlexNet, ResNet, GoogleNet. So all these beings are developed with these many layers of neural networks, and these are all being used in a competition where we call it as ILSVRC. So these competitions, they have been conducted, and they are judged as the best models for for analyzing certain diseases as well. So some of the metrics what we normally use to evaluate a particular AI model is its accuracy, is its sensitivity, is its specificity, and its positive predictive rate, how much positive it's being predicted, and F1 score as well. So the definitions for each and everything I've given here. So what we call here these models as a confusion matrix. So confusion matrix, in the sense, it may be calling it as true positive, true negative, false positive, and false negative. So true positive is your the model is also giving the correct result, and it has been validated by, a gold standard is also being the same. So that we call it as a true positive. That is, this particular image or this particular patient is deceased. So this particular patient is not deceased. That becomes true positive and true negative. And false positive and false negative, opposite diagnosis. So, and again, I'm not going deeper into this here. So ophthalmology, it is a simple what to our understanding. So it is a branch of science and surgery that focuses on the diagnosis, treatment, and prevention of disorders related to human eyes, or the visual system, what we focus on. So that is the scope of ophthalmology. So again, this is purely a generative one. So comprehensive eye care, medical treatment, surgical interventions, pediatric ophthalmology, neuro-ophthalmology. This is gaining importance nowadays in artificial intelligence, and how AI can be deployed for neurology, neurologic science, and ophthalmology. Then glaucoma management, and the last one will be the lifelong learning, that is research and education. So some of the common eye diseases where artificial intelligence are being deployed is diabetic retinopathy (DR), and glaucoma, cataracts, age-related macular degenerations (AMD), then retinal detachments, and pink eye disease, that is conjunctivitis. And this last one is keratinocosis, is just an upcoming one. Very less papers are being used integrating AI and this disease. So it is just on the budding aspects. So why do we go for I mean early diagnosis and treatment? That is for what we make use of artificial intelligence. So early diagnosis will always aid in prevention of vision loss. So not normally glaucoma, we call it as silent thief. That is silent thief of vision. So prevention of vision loss, and for the improved treatment outcomes, that is this point will be, dealing it with telepathy, tele-ophthalmology, then enhanced life quality, then cost-effective treatment that is mainly used for developing and underdeveloped countries, and how do we monitor the disease progression, that is starting from initial stage and how the disease progresses, and again education and awareness, and we have to track on the technological advancement and how each and every technology is being developed using AI for the early diagnosis and treatment. So the simple thing what I need to push is how we integrate artificial intelligence and ophthalmology. That is integrating ophthalmology for predictive analysis. That is number one. Number two is personalized treatment plans. Number three is automated image analysis. Number four, operational efficiency. And number five is telepathy. So after these things, my slides will be focusing on all these areas. And the three important applications of artificial intelligence in eye care is segmentation, diagnosis, and prediction. So segmentation, in the sense, I just put it in as a simple terms. So we might have seen about a fundus image. So where we have optic disc, optic cup, etc. So the normally what we do in our analysis using AI is we segment optical cup and optical discs from fundus images. So one of the biggest challenges what is ever facing still nowadays is the segmentation of OC, optical cup. So optical disc, somewhat we are getting some diagnosis, but optical segmentation is again a big challenge for using artificial intelligence in eye diagnosis. So why we calculate or why we go for OC and OD is calculating the disc ratio, optic disc to optic cup ratio. So we also make use of those analysis to diagnose whether this particular segment is a deceased one or which is a not deceased one. So that the same kind we also make use in DR or AMD, whatever it may be. So the same thing, that is segmentation, segmenting each and every portion of the fundus image. So we also segment the optic nerve. That's also a part of the AI being used here. So the simple thing, predictive analysis, what we call it as, there are many startups that are being developed in this predictive analysis. They are leveraging the predictive models that make use of AI to forecast the progression of any disease, either it may be a DR or AMD, whatever it may be. For example, if you take and analyzing a retinal image, we can predict the risk of a patient who may be at the verge of developing retinopathy or a severe deviopathy in the next years or in the next few months to come, with an appreciable accuracy, what we can call it as. Then personalized treatment plans, that what we call it as, there are certain artificial intelligence platforms which are customized, for example, customized treatment regimes which are available nowadays, which the companies what I have listed before. So they make use of, they provide certain personalized treatment plans for each and every individual based on the individual data. So individual data what we collect, that is from the hospitals, that we there are certain ethical constraints as well for collecting all those details. So we need to get ethical clearance from the particular government, from the country's government, or there are certain norms and regulations where we need to follow. So all these things we get clearance, and then only they start using their personalized treatment plans for these are some exemplified artificial intelligence models suggesting intravitreal injection schedules for patients with wet AMD, with AMD, significantly improving the treatment. This is a simple one example what we scout from the companies what I have listed before. Then automated image analysis. For example, if you take automated analysis of ocular images, that is fundus image or OCT, whatever we have, is perhaps the widest application what we make use of AI in ophthalmology. So the companies what I have listed before, they create their own software which can detect and grade cataracts as well. So, or glaucoma, whatever it may be, from certain fundus photographs with a level of precision, some level of precision that is comparable with experienced clinicians. So both can be compared for how this software is working well, how this software can be validated. So everything has to be validated only with clinical data, how the ophthalmologist or the clinicians provide the data. So we have to compare those things, then only you'll be able to validate this software is okay, this software is not okay. So those things will come under personalized treatment plans, which are persistent or customized to certain companies as well. Then operational efficiency. So beyond certain clinical applications of artificial intelligence, machine learning algorithms are optimizing clinic operations by predicting patient no-shows, and they also help in manage appointment schedules, reducing the wait times of patients, and improving customer satisfaction or patient satisfaction, whatever we make use of. Then the last one is the tele-ophthalmology, very important concept nowadays, which is gaining importance or gaining the attention. Tele-ophthalmology, we make use of cloud technology here, integration of AI. Tele-ophthalmology services are now becoming applicable for remote diagnosis. Remote diagnosis, monitoring eye conditions, beneficial in underserved areas, better served in underserved areas or under privileged areas, what we may call it as. So by intertwining AIML in ophthalmology, certain startups which have been developed are not only revolutionizing the patient care, they also set a precedent for future medical specialties. So this can create a better paradigm, that is paradigm shift towards a proactive and personalized healthcare. So this is a simple system of ophthalmology where I have consolidated everything here. So artificial intelligence, machine learning, EMR, that is electronic medical records, machine language processing, unstructured data, and clinical evidence. So from everything we get a data. So while we start from artificial intelligence, they have two wide areas: machine learning and deep learning, and natural language processing. So for the natural language processing, you may get the data from an unstructured data, which may be a human language. So this data has to be generated again. So for that, we make use of natural language processing. So that natural language processing will produce an output. So that output will be given to will be in the form of a diagnostic report. So this diagnostic report becomes an input to the AI model or the machine learning model that is used for the disease diagnosis, and this output from the machine learning will be used for diagnosis screening. So this is again a loop one. This is a feedback loop. So again, disease diagnosis, again it becomes an input to the natural language processing as well. So this is an interconnected one. So the unstructured clinical data, that is input data, what we call, is again converted into a structured data. That is done using your natural language processing. So this obtained natural or the output structured data become an input for the AI algorithms which make use of AI and ML. And the output from the machine learning is again given as the input to the clinical diagnosis as well. So this is a simple outline of where artificial intelligence models are being developed for eye detection, eye disease detection. So this is a simple diagnosis of artificial intelligence systems in ophthalmology, which consists of, for example, we have taken AI in glaucoma. This is glaucoma screening, glaucoma diagnosis, predictive analysis, personalized treatment, outcome improvement, and patient education. So you also need to educate the patient depending upon this how this particular patient diagnosed with glaucoma can act in the next few years. So how this disease can be we cannot prevent the disease, but management and control of the disease is possible. So for all these things, we require patient education, these things, the input comes from the data collection. Though data collection may be from any technology you can now use of simple, they can go and get it from wearable technology. So this is general data, wearable technology in the sense we have smartwatches. So the data from the smartwatches is being used for a variety of applications, not for ophthalmologists, but it is generally used in sports persons are making use of this wearable technologies where the prediction is possible. And glaucoma screening, it already produces some real-time applications where we can work on real-time image analysis. And glaucoma diagnosis, it may be in the form of an OCT or it may be a fundus image. So you can combine structural test and functional test as well to create a hybrid model. And this predictive analysis, this plays a very important paradigm shift, which is particularly pivotal, where leveraging cutting-edge algorithms can make a difference in the early detection of ocular diseases and any missed opportunities also we can have. So that is normally this predictive analysis now gaining importance in vision transformers, what we call as the YOLO transformers, YOLO. These transformers are now gaining importance in monitoring the disease progression. So this early disease detection, what we have is diagnostic parameters in case of glaucoma. So they are based on certain structural and functional description of the disease, where we can have optic nerves gets damaged and which results in ultimate vision loss. So this, using this simple technique, we develop the artificial intelligence based on the certain aspects of like what I said in the before, that is calculating the interocular pressure or calculating the optic curve to optic, OC to OD ratios. So all these things will help in diagnosing or differentiating whether this particular patient is glaucoma affected or this person is not glaucoma. So some of the techniques which are being used in artificial intelligence and which serves as an input is your fundus image and OCT images and visual field analysis. We are not taking the third one. First 1, 2, and 4 are now being used for application of artificial intelligence in glaucoma diagnosis. And this, I've given it as another model where this use of artificial intelligence combined with deep learning networks. CNN, what I give an example in the previous slides, like AlexNets, VGGNet, and ResNets. So all these are being involved in creating a deep learning algorithm for detecting of a clinical data, which is maybe a multimodal technique as well. So it may be from a fundus image, it may be from an OCT image, whatever it may be. So selection of data set, that is again forming one of the important component. Then pre-processing of the data, what we get, and certain important softwares I have given here where our DL systems will work, Keras, TensorFlow, Python, and developing certain heat generated maps for occlusion test, attention maps, etc. So these are some of the important terms what we use in artificial intelligence, where area under curve, AUZ, we call it as accuracy, how the particular model developed, either it may be VGG or combination of VGG and ResNet, how this model works on certain images as well. So this I'm skipping again. So this AI in diagnostic images, these are the images what we use for as an input image for our detection system. That is fundus image of AMD, glaucoma, myopia, and DR. So these are the sample images what we use for the, disease diagnosis. So early detection, increased efficiency, and enhanced accuracy. So these are the three key areas where we focus on how an artificial intelligence is being used in diagnostic imaging. This predictive analysis is an important field nowadays, which is gaining importance in eye disease. So it is used in diagnosis, prognosis, clinical support, and reducing health cost, remote monitoring, whatever we may call it as. So early disease diagnosis again, before that is forecasting the onset of any disease like DR or glaucoma, enabling preventive measures which can be taken, if possible, much earlier. Then personalized treatments that I have already shown. Then patient engagement is very important point here. Patient engagement, that is engaging patients in their visual health, is very crucial. Thus, for example, some companies have developed an app that might predict the progression of myopia in children as well, and suggest their life cycles, how the life cycle gets changes or slows down to its advancements. So many startups are now developing certain applications, that is apps, which predict certain diseases by just clicking the photograph of their eye. So again, the other point, that is cost reduction. The predictive analysis can identify the patients at risk of post-operative complications, allowing for certain interventions at costly emergency care. So all these things can be avoided by using predictive analysis. And the foremost thing what we can have it is identify certain patients, risk patients at their homes, and timely treatment. So these key uses of predictive analysis, which can be done using artificial intelligence. But again, we have to reiterate that no model is 100% perfect yet, and it is again 100% error free, and sorry, I'm mistaken here, and it cannot replace the specialist at any point of time. So sorry for the mistake in my slide. So, and this tele-ophthalmology, which is gaining importance nowadays, and these tele-ophthalmology platforms are being developed nowadays by certain companies, which allows them for remote diagnosis and monitoring of eye conditions. So the doctor can sit from his room or from the hospital, and he can monitor the patient's progression of the disease at very point of time. So all these things is what they need is patients can capture the retinal images or VFT test at home itself, analyzing, or which will be analyzed by certain AI algorithms or the apps which are being developed by certain startups which are coming into customized use nowadays. So this tele-ophthalmology, again, it is a very important medical term. What another terms use, cloud internet of medical things. Internet of medical things is now gaining importance, what we call it as IMOT. Architecture is a simple architecture that is being developed. So an ophthalmologist is also being involved. A patient has a wearable device where where his eye images or eyes are being captured using a mounted lens, and this being given to a VPN network. So this again forms a cloud-based architecture, where the what we call it as IMOT architecture headset. That is the entire thing we call it as headset, that is used to capture the collection of patients' retinal data that is being captured here. And this is a simple architecture where it is an coalescence of IoT plus healthcare, which is transforming the healthcare industry at present. So normally we make use of the term mobile-based health technology, that is M-Health. So you might have we might have witnessed these things in certain company applications, where this M-Health can be used, sort of giving certain personalized images to certain applications. So if you are diagnosed with high pressure, if you are diagnosed with certain disease, so personalized health plans are also being dealt. So how we can plan for financial services, financial healthcare plans, so financial plans, how we get. So similar kind of healthcare plans are also available in certain apps which are developed for M-Health. So that is a big data. Here the term comes as a big data, that is big data analytics and cloud computing. Cloud computing both make use of UIS, that is user interface service. This is again IoT enabled healthcare service, what we call it as a resource allocation manager, RAM, what we call it as resource allocation manager. So this will predict certain services or the physical resources. IoT health managers and prediction process, all these things will take under the cloud. So where the data of a particular patient is stored in the cloud, retrieved at any point of time, and used for further processing. So that has been taken place in case of this IoT based architecture. So coming to the last aspects, that is what may be the lacuna in the existing approaches of making use of AI in healthcare or in ophthalmology is inconsistent data quality. What we obtain is not fair, and there is biased collection of data. That is lack of uniformity in data collection. That is in previous slides would have told you about certain images where we get Kaggle for fundus image. There are different rim1 data set is there. There are a huge number of data sets available. So all these sets, they are biased in nature. So that is what we call as lack of uniformity, and there is no standard biomarker for any particular disease. For example, well, you take glaucoma. So, which is an important biomarker for this disease. So, we cannot predict using this artificial intelligence. So, there may be a genetic process, there may be any kind of biomarker that may be available, but there is no standard biomarker that is being diagnosed using the artificial intelligence. Again, we can go for there is lack of research that demonstrate any fundamental link between genetic variation or biological function in disease diagnosis. Then what the challenges and limitations what we get is data privacy. Again, I told you getting ethical considerations is very mandatory in that is taking the patient's data outside for research purpose. That ethical considerations are also available, and if you need any deep learning model to be deployed, you need a larger data set. That is deep learning models are hungry for data. So that is diverse data sets and huge data sets are required to validate a particular model. So we cannot validate a particular model using 100, 200s and 300s of images. So they need to go for in hundreds and thousands of images where you can validate a particular model. This model is good for this thing. This model is good for this thing. So that we cannot say without huge and diversified data sets. Again, this model has to be have an acceptance and trust among the healthcare professionals as well. So the last one again is a general topic. So this has to be validated by a clinical person, or this has to be clinically validated before deploying a particular model for any disease diagnosis. Then the future resource, it can be future research can be based on creating a larger public database for any kind of disease disorders, for any developed model what we can use, that is for validation of those models. And for if there is no certain, there is no particular model which can be diagnosed or which can be good for a particular disease. For example, this model is good for glaucoma, this model is good for MD. We cannot have it, because everything is based on a longitudinal data, and your research will be shifting upon the CAD systems for any ophthalmic diseases whatever you make use of. Then remote access by non-experts, that is in places where we may not be, many specialists will not be available, like remote areas and villages. We may make use of this cloud-based systems, or that is medical internet of things. Though using those things also, ophthalmology can also play, but that has to be reached to a next level, which is at a preliminary level nowadays. So more research has to be focused on teleophthalmology, which will serve the underprivileged areas from developed from any region of the world, that is underdeveloped areas or underprivileged areas. So these three areas are the major areas of research focus what this AI and any sort of branch of science which deals with healthcare is being involved. So it may be either ophthalmology, or it may be a neural, or it may be a psychiatric disease. So that's the thing from my point of view. And to conclude, and in healthcare sectors, artificial intelligence helps to reduce time, helps to reduce certain cost with a better diagnosis, better prediction, and treatment of disease, which may be either control of disease, or it may be in the management of disease. So again, researchers are again working on AI projects which will be a boon for the humans and in the upcoming years. So what the thing nowadays it goes is brain computer interface which can help the patients who are physically challenged, that is physically disabled or suffering from spinal cord injuries. So all these things will come under a general application of healthcare industries with AI. So again, the healthcare industry is a complicated one, complicated science, which is bound by legal, ethical, economical, and social constraints, and can be implemented with AI by making parallel changes in the environment. So that's the slides from my side, and if any queries from your side, I'll be able to answer.
At this moment, we can take any questions from the audience. You are free to also write it in the chat. While people decide on their questions, I do have one question for you. One of the biggest things with AI is that trust with people. That's very divisive, where one half of the population seems to be like, I don't want anything with AI, the robots, and the other half is very accepting of it. It seems from your presentation that the first field to be really impacted is image-based medical diagnostics, so
Yes.
radiology and such. What would you tell a currently studying medical student who's trying to get into radiology, or a resident in radiology, about these developing technologies because of the fear that it might eventually take their job?
So from the presentation, or from the point of view, that is, AI is just an aiding tool. It may be a second expert to the clinician. So it cannot replace the humans, or it cannot replace the diagnosis done by a clinician. So it will be a second opinion only. So there is no perfect model nowadays to replace all these categories. So I can say that this particular model is good for glaucoma detection. This particular model is good for AMD detection. There is no such models available, and you can just help or keeping on improving your diagnostic accuracy, which has to be mapped with the clinicians. So we cannot we cannot outlay the decisions done by the clinicians, but there may be some human errors as well. So those human errors can be avoided in certain cases using this AI models. So that's what we can start from this point of time. And this AI models, which are developed by certain companies, which is listed by, so they develop certain specialized applications which will give you. So for example, you take smartwatches. So they are able to monitor our blood pressures, they are able to monitor our that is walking style, how many steps you have done. So all these are making use of sensor technologies. So these sensor technologies and IoTs, again, these data are given to a cloud based architecture, and this artificial intelligence will manipulate those data depending on certain data, and they will produce certain output. So that is what we can do here. So we cannot say that this is correct, this is wrong. That is not possible, sir.
Thank you so much. And then in the chat, Dr. Nita has written, please guide whether AI-based study in optometry is good project for a PhD project. So is it a good PhD thesis?
See, actually, my PhD thesis is application of AI and machine learning techniques in glaucoma detection. So it is my PhD thesis. So it is a good opportunity to make use of, or better to develop an application, that is app, combined with your PhD project. So for example, if I supply a retinal fundus image, it should produce an output. It is glaucomatic image. It is non-glaucomatic image. So you can develop those kind of applications as well. That is combining your optometry with AI.